Hello, good afternoon. Thank you for coming. My name is Alan Gates. I'm one of the founders of Hortonworks, and I'm also a member of the Apache Hive community. And I'd like to talk to you today about some of the things going on in Hive, particularly the new release of Hive 2.0. So I'd like to start with some acknowledgements here. I'm talking as a representative of the Hive community, but certainly this work was done by the whole community. Right? This represents engineering years worth of work that's gone into this. And so I just want to start out by calling out the Hive community for all the awesome tech they put into this. And also want to acknowledge that I stole some of these slides from a few other people. And then start out with, I'm going to name a lot of Apache projects in here, and in the interest of space on my slides, I didn't always put Apache Hadoop, Apache Spark, whatever. So there's your list of, all those things are actually Apache projects. That way, I've called out the Apache-ness of it all without cluttering up my slides. So let me talk a little bit about what I mean by Hive 2.0. Why is there a 2.0 version of Hive? Over the last year in the Hive community, let me back up a little further. Over the last several years in the Hive community, as you guys know, if you've followed Hive at all, there's been a lot of development. The pace of development has really picked up. And Hive has really started to transform from what it started out as, which was an ETL engine that you could, basically a way to translate SQL into MapReduce, into something now that people still certainly use for that, but they also use for analytics, for data warehousing, for a number of other purposes. And that speed of development's good, it's exciting, it brings lots of new features, it makes for a vibrant community. We've added many, many committers, many new contributors over the last couple of years, but it also creates a little bit of stress for contributors and users who were frankly happy with what Hive was before. For them, all these new features are pouring in. They keep asking, why should I care? Why are you doing this to me? Why are you changing what I love? And so we agreed as a community that the good way to handle this was to start to have two streams, because we knew that going forward there would continue to be changes, and you'll see kind of the first version of some of those. And this pace of innovation was going to continue or perhaps even accelerate, not slack off. And so obviously we want everybody in the community to be able to participate and be happy with what they have, and we felt the best way to do that was to start to break this out. And to do this in the same way that the Hadoop community did a number of years ago. We would branch out and have a 1.x line, what we call branch 1 in our Git repository. The focus of that line is it's stable, it's backward compatible, but we continue to develop there as far as bug fixes. Even new features can go in there if the developers want to, so this is not a maintenance-only line. Don't think about it that way. But the rule here is you can't be breaking stuff, right? You can't say, I have this great new feature, only it doesn't work with MapReduce, or only it doesn't work with Hadoop 1. That's not, you can't put that stuff in branch 1. Branch 1, you're guaranteed that things work in the legacy world. In the 2.0 line, on the other hand, that's where we want to start to put in the big new features. We want to be backwards compatible wherever possible. We don't want to be capricious about that and just break things for the heck of it or because it's fun. But sometimes we're going to break some stuff, right? There's just some things that as you move forward, we're not going to be able to maintain the old compatibility. So our first release of Hive 2.0 was on February 15th of this year. I want to stress it's not production ready. It is a 2.0 release. And I cannot, in good faith, recommend that you put it in production or use it in any system that you really have to have up and running all the time, but it's there to test with and work with if you want to see the new features, and hopefully over the next release or two we'll get that stabilized to the point where it is something you can confidently deploy into your production systems. So a lot of work went into Hive 2.0, as I already said. Over 1,000 JIRAs were resolved in this 2.0 version. Many of those, approaching 700, were bug fixes, but 140 were improvements or new features. So there's a lot that went on here. Obviously, I can't sit here in 40 minutes and cover 1,000 JIRAs worth of work. I can't even cover the 140 Jira's worth of improvements and new features. So I picked out some things that I thought were particularly interesting to share with you that I'll cover, and then but I just want you to know that there's way more than this going on. I'm kind of hitting the highlights. So I want to talk about the fact that we've added procedural SQL to Hive, the new LLAP work, which is work to vastly speed up Hive's query execution for certain types of queries, work to enable storage of the metadata in HBase if you want to do that, improvements to Hive on Spark, ongoing work on our cost-based optimizer, and then many, many more things. So let's start with procedural SQL. If you guys are familiar with Oracle or Teradata, any of the big commercial databases, for a long time now they've had procedural SQL, what Oracle calls PL SQL, for use in stringing your queries together, often to do ETL type operations. Basically, it adds Turing completeness to SQL, right? Because SQL proper is just a query language. There's no branching, no looping, no exceptions. That adds, PL SQL adds that to SQL. And so we received a major contribution from the community, from the Hive community, that adds this to Hive. And the aim of HPL SQL is to be as compatible as possible with the major dialects out there of procedural SQL, so that as you migrate, as you as a user come to Hive, or maybe as you migrate your workloads onto Hive, the impedance mismatch there is as small as possible. Obviously, it can't be compatible everywhere because all those other versions of procedural SQL aren't compatible amongst themselves, but we wanted to minimize the friction there. And then the other thing to know is right now this is external to Hive. It was originally built as a separate project where there was a separate binary that you would submit your HPL SQL script to, and it would connect to Hive via JDBC and execute just the SQL part while it managed the looping and branching. That's still the way it works today, even though we brought it into Hive. Our goal over the next few releases is to actually integrate this deeply into Hive, so it will be part of Hive itself instead of an add-on. So this is just a step one. The next area I want to cover just briefly is work toward getting to sub-second query processing with LLAP. You've probably heard us talk about this before. And I'm going to talk just a little bit about what this does and how it works and some of the performance we've seen. If you're interested in the deep details of this, Sergey, who's one of the engineers on our team at Hortonworks, who is deeply involved in the LLAP project, is going to actually go through the internals, give you all the nitty-gritty details. So please, if you're interested in that, make sure and catch his talk. I believe it's at 5 o'clock this evening. So what is LLAP? It's the addition of persistent daemons so that we can answer queries very quickly, right? If you think about traditional MPP data stores, like such as Teradata, they have a bunch of standing servers, which has the advantage that they can answer certain queries very quickly, but then struggles a little bit when it comes time to scale widely, right? Hadoop has the inverse set of strengths and weaknesses. It scales very nicely. It's very dynamic, but it struggles a little bit about being fast because it has to spin up containers and all that. What we're trying to do here is take the best of both of those worlds. So we're not saying that Hive always needs to use LLAP or always should, but for certain query loads, it makes sense to have a persistent set of daemons. These daemons can cache the hot data sets, and it's not just certain tables or certain partitions, it's even certain columns and certain groups of rows inside those partitions, right? So the cache can be very intelligent about which piece it's keeping in memory, because often we find, you may have a table with 100 columns in them, but 90% of your queries probably only touch 10 of those columns in that table. So it doesn't make sense for us to cache the entire row. It only makes sense to cache those 10 columns. And since LLAP is tightly integrated with Hive, it understands the data, the structure of the data. It can choose which of those columns to cache and which not to. This is more than just a cache. We're not just storing data in memory. We actually are able to push execution down into LLAP. So when it makes sense, and I'll show you a graph here of that in a minute to get an idea of what this looks like, we can actually run our operators inside LLAP. So there's certain queries that you may choose to only run some, that the system may choose to only run some of the operators in there. There's some that make sense, you can just run the whole thing in LLAP. There's no need to run it anywhere else. And then finally, we want to open this up to other systems. We want this really to be a table service, right? So if you're, say you're using Spark SQL, you'd like to read a Hive table, you'd like still to have all of Hive security, the column encryption stuff, work that's going on in Hive, you'd like all that to still be present. We want to give a way for systems like that to read in parallel from this so that it can act as a table server to these other systems. And we've actually already started work on doing that integration. LLAP is beta in Hive 2.0, so that's already been released. You can stand it up, you can play with it. We do see really good results with it, and I'll show you some of the performance numbers in a bit. I'll just be upfront and say the usability, it's a new product. I'm not sure all the tools are there. So I encourage you to try it, but I encourage you to set aside a little bit of time when you decide to try it. It's not going to be something you're going to run and have up and running in half an hour. So what does execution look like in this model? So on the left side, here you see kind of the traditional Hive model where there's a set of tasks. They run in individual different containers and shuffle data between them. That's how Hives worked. In this particular picture, we're using Tez as the execution engine, but it would look the same if you were running it in Spark or MapReduce, whatever your execution engine. You have this same separate set of tasks, separate containers, and shuffle. In LLAP, as I said, you can start to push some of that processing in. So in the middle example here, each of these represents an LLAP node. And so you would start to push some of those tasks up into LLAP, but you might still shuffle them out into Tez to execute the remainder of the query. You might choose to do this, for example, if you have a large join happening here that it doesn't make sense to execute inside your LLAP. And then for a certain set of queries, say that you're going to do a simple star join followed by a group in an order, you know that you already have a lot of this cached, you can fit the data easily in memory. You can do something like this where you execute the entire thing. So in that case, it can actually act much more like a traditional MPP store. So what kind of performance numbers do we get out of this? We have benchmarks that we like to run based off the TPCDS query set. This is run at a 10 terabyte scale on 20 nodes where we're giving 512 gigs 10 nodes where we're giving 512 gigs on each machine. So we can't fit everything in memory, but we can cache the hot parts of the data set. And these are the kind of response times we saw. Now, these are not all of them. I'll show you the hold in a moment. This is kind of the highlight because this graph's a little easier to read. But it gives you an idea of the kind of query times we're seeing here, around 5 seconds. So the blue is Hive, I believe this was run against Hive 1.2, I think. And the green is top of trunk with LLAP work. So we're seeing most of these queries are in the 5 to 10 second range. Now here's the kind of the bigger graph of all of them. So, it is a new product. We're not faster on everything, right? You can see some queries here where it's actually slower than the old stuff. Some of that's because those queries may not be appropriate to run in LLAP. As I said, some things will run better in the old style. And some of that may be just bugs we need to work out. But you can kind of see there in the box, you get an idea of 38 out of 61 of these queries were at least 50% faster. One query was actually up to 90% faster. So we're pretty happy with that as kind of a first step out of the box. How's this stuff going? So limitations. As I've mentioned, it's in beta. Second limitation right now, there's only a read path. There isn't a write path through this right now, which means that it doesn't work with the ACID work that we've been doing in Hive, because we can't, ACID's a little hard to do when the writes are coming in outside of LLAP. So that's future work we need to do to integrate those two and make them work together. The next limitation, and this is kind of it's an irritating one, but it's there for now. Right now, our cost-based optimizer doesn't know when you should use LLAP, when you should use that mixed mode I was showing, and when you should do it totally outside. It's clearly something an optimizer can figure out, but we haven't done the work to build the costing algorithms and answer those questions yet. So today, you have to do that manually, which clearly is not where we want to end, but it's where we're at today. Currently, it works with ORC files as a storage, and it uses TES as an engine when you need to shuffle out. And it actually interacts some with TES. Even in that case I showed where you're doing everything in LLAP, it actually still uses TES's AM, the application manager in Yarn, in some ways, so it needs to have TES there. All right, so that's kind of on the execution side. In that graph I showed, you might have noticed many of those queries didn't go below 5 seconds. Or, well, I think there was one. I think the very fastest went at about 2.5 seconds, 2.5, 3 seconds. We're at a funny place now where on some of those queries, we actually can execute them faster than we can plan them. That one query that finished in whatever it was, 2.5, 3 seconds, 2 seconds of that was planning the query. The other half to 1 second was executing it. That's particularly embarrassing because my particular area of expertise is the planning and metadata access. So not happy about that, but that's where it's at. So that means, what do we need to do next? Obviously, we need to speed that up. When we spend time looking at why is it taking us so long to plan these queries, why is it 2 seconds to plan a query that we can execute in half a second, the answer is a lot of that time, not all of it, but a lot of that time is spent in metadata access. So we see this in queries. That particular query I was talking about with the 3-second timing is, it has, I think it's several thousand partitions, something like that. I might have the number wrong. Maybe it's 1,000. I don't quite remember. But the basic idea is it's got a lot of partitions to pull information about out of the metastore. We're not very fast about that. That's where we end up taking a lot of time. So what do we want to do about that? One of the things we want to do about that is speed that up by making the metastore access much more efficient. And so we've been working on making an option, and I want to stress it's an option, you're not forced to do this, to use HBase for your metastore. So why would you want to do that? Why is that a good idea? Right now, when Hive stores its metadata in a relational database, it uses an ORM layer because it has to be able to talk to, well, one, because somebody has to do the translation from Java objects to SQL, and it's easier to let an ORM layer do that than to hand code your SQL. But also because Hive supports, I believe it's 5 different backend databases, because everybody has their favorite database, right? And you want it to support it. Well, that makes for a nasty ORM schema. ORM layers aren't known for speed or simplicity. And also the fact that we support 5 different databases makes it really hard to tune to any one of those databases, right? If you're just going to run, if you just said, you know what, all we're ever going to run is Postgres, just to pick an example, you could tune tightly to Postgres. You could go figure out, what do I need to do? You could hand code your SQL, but we don't have that opportunity, or, well, we do, but we'd have to hand code to 5 different databases, which we just don't have that kind of time or patience. So being able to pick something like HBase, where I can hand code a little bit more to that, solves that problem. Also, using an RDBMS limits our caching and connection opportunities. So there's a lot of metadata we'd like to be able to cache. For example, ORC stores, the file format stores a lot of information in its footers, statistics and indexes about what data is in there. It's very advantageous to us to be able to cache that in the metadata so that we can read that when we go to plan the query, rather than having to go out to the file system and actually find the file, open it, and scan that portion. It's hard to do that in a single node relational database. Now, obviously, you know, you could go buy Oracle RAC or something and you could store as much as you wanted in there. But if we're out selling some open source solution, but oh, by the way, you have to buy a super high-end relational database underneath to make it all go, that's kind of a weird message, to put it mildly. So HBase solves that for us, right? It scales very well. It allows many, many connections. allowing many connections opens up the possibility of actually connecting to the Metastore from inside the cluster, something you can't do today because we just, a single node relational database can't withstand hundreds of things connecting and disconnecting all the time in a super easy way. HBase addresses each of these. So what's our goal? Our goal is to cut metadata access time for a query with several thousand partitions down into the 200 millisecond range. We're not there yet. The work we've done so far, we've gotten to about 1 to 1.5 seconds. That's about half of what we were at before. So we're not done here. There's a lot to do, but we're working on that. This is also in Hive 2.0. This is definitely alpha. I can't recommend that you play with this unless you want to help us develop on it, in which case, please play with it, please help us. We love contributions. And a challenge there is obviously HBase lacks transactions, and you need transactions for some of these things. You don't want to go to drop a table and have half the partitions vanish and half still hang around. That wouldn't be a cool result. So we're going to use Apache OMID, which is a recent addition to the incubator. It's a project that came out of Yahoo that adds a transaction management service on top of HBase. Okay, another area where there's been a lot of work going into Hive 2.0 is improvements to Hive on Spark. So I believe Hive 0.15, I think, was the first release of Hive with Spark in it. Or sorry, with Hive allowing you to use Spark as an engine underneath in addition to Tez or MapReduce. So a lot of work has continued to go into this. They've added work on better dynamic partition pruning. So one of the issues that Hive had traditionally in the past is it wasn't super good at figuring out on the fly which partitions it did and didn't need to read if that wasn't explicit in the where clause of your query. Sometimes as you do a join or something, it becomes obvious which partitions you do and don't need. They've done a lot of work to improve that when you're using Spark as an engine. They did work to make use of Spark's RDD features to persist common sub-elements in a query. So if you reuse the same element, the optimizer can figure that out, instantiate it once as an RDD, and then reuse it. So for example, if you self-join on a table, it only has to load that up once rather than do it twice. They've added vectorized map join and other map join improvements. This is kind of taking work that was already available on the Tez side and porting it into the Spark side. And Spark has underneath an option to do order by in parallel. By default, Hive always does order by in a single node at the end, which usually works out because usually you, by the time you get to an order by, you don't have tons and tons of data left because you're usually going to present it to a person or a tool by the time you're ordering it. But sometimes you do have more than that, and so they're making use of the order by functionality that Spark already has to do that. And another big one is pre-warming of containers. So when you open a Spark context, you start getting containers assigned. If you jump into that right away, you may not have all your containers assigned yet, but Spark will let you start running. However, Hive bases its parallelization choices on the number of containers it has right at that instant, rather than the number it's eventually going to get. And so you may only have, say, 50% of your containers, and then you start making your calculations based on that. So they did some work to instead make sure that when you connect, it starts to pre-warm those containers, may even pause for a second or two to let those spin up so that you have the full power of what your cluster should be using instead of just whatever happened to be there when the query started. And then they've added support for Spark 1.5. I don't actually remember what it was on before, but it was several back, like 1.2 or 1.3, I think. And then lots and lots of bug fixes. Okay, another area where a lot of work has gone on is the work on cost-based optimizer. So Hive's had a cost-based optimizer for a while now. Hive is using Apache Calcite to do this the optimization underneath. This is a package that's used by Hive, by Drill, a number of other Apache projects are using this. So It's been an excellent place that we can collaborate with all these other projects and reuse each other's code. Hive did have its own optimizer beforehand, so in our first initial integrations, we just used the Calcite for some things and continued to do some optimization on our own. That's still somewhat the case, but we've moved more and more of our optimization into Calcite. We're not there yet, to the point where we can throw away all of our old stuff, but we're continuing to grow that use. The other big thing is we turn it on by default now. So in the earlier versions, the CBO was there, it mostly gave right answers, didn't always give right answers. I don't mean data answers, I mean as far as choosing the best plan. And so we didn't turn that on by default. We recommended that you start with it off and only turn it on once you tested with it and were sure that it did the right thing. Now we're confident enough in it that we actually turn it on by default. So we feel that more often than not, it does pick the best plan, and the best is a strong claim. A better plan than we would have picked if you didn't have the cost-based optimizer on, and so we use that. We have focused, as we've done this work on the cost-based optimizer, we focused mostly on BI-type queries and analytics-type queries. So, and then also some work on queries generated by machines, meaning other software applications, because they do some funky things like group by a constant rather than put in no group by clause, because I guess some SQL engine somewhere at one point in time didn't allow you to group without a group by clause, so they'll say group by one, and they don't mean column one, they mean group by one, the constant, so you have to be able to handle stuff like that. I mean, your optimizer has to be able to look at that and go, well, that's stupid, that's not what it really means. So we've done some work on those sorts of things too. We've also done a lot of work in there on improving statistics collection and estimating stats more accurately between operators. So you collect statistics and you store those automatically during load and that kind of stuff. But so that's important. We've done work to improve that. But we've also done a lot of work around improving, okay, this record's going to go through a filter. I'm going to put 1 million records into this filter. How many records are going to come out? You have to make some kind of rational estimate about that. I don't want to give the impression that we've fixed all that. There's still a fair amount of work to do there, but it's much better than it was in the past. Okay, and as I said, there's much, much more there beyond just what I could talk about. Let's see if we've done a lot of fixes and improvements and bug fixes for ACID. We've done a lot of work to beef up Beeline as a CLI mode, and I'll talk more about that in a minute. Improvements to Parquet performance, all kinds of things going on there. I'm not going to talk about everything on this slide just in the interest of time, but I wanted to kind of throw it up there and highlight it so you guys have an idea of kind of the breadth that we're moving forward all across the stack, right? We're improving scale, improving speed, we're improving the SQL coverage, improving usability. Actually, I didn't get that in the title anywhere, but that has been one of the big focuses. Usability and administrability, if that's a word, I don't know if that's a word or not, of the system. Okay, so I alluded to at the beginning that try as we might, not everything could be backward compatible, so now the actual revelations, what did we break? So here's what we broke. We only run now on Java 7 and 8. We no longer support 6. 6 has been end of life for a very long time, so hopefully this isn't going to cause too much heartache. We're actually discussing now in the community, when do we end of life 7? We're looking at, I think the discussion is kind of moving toward we'll develop, because right now we develop on 7 and but it'll run on 8. We're looking at flipping that to we develop on 8, but we'll still target 7 so that you can, because we know a lot of people are still running 7 in production. Okay, so another thing we broke, this requires Hadoop 2.x. We do not support 1.x Hadoop anymore. Again, now this one I do actually know some people still running in the 1.0 line, but hopefully for most of you this isn't a deal breaker most people have moved up to newer versions of Hadoop by now. MapReduce is still supported, but it's deprecated. We believe that Tez or Spark are the way forward as far as engines underneath this. So we will for some time still support MapReduce, but at some point in the future that will no longer be the case. Hopefully as Hive users you actually don't care. Hopefully what you care about is that the system runs efficiently and correctly, and whatever engine's underneath is just kind of a detail, but that's somewhere we're moving with that. There are some default configurations that are changed. Big examples of this that people ran into as soon as we released Hive 2.0 was we no longer auto-generate the schema in the Metastore database. It used to be if you hadn't provisioned your database and you connect to it the first time, the ORM layer would go lay it out automatically. That's kind of nice from a take it out of the box and try it perspective, but it's actually bad from a maintenance and correctness perspective, because if you start with one version and switch to another, or the system gets the tables half built there, you can get kind of odd results. So we turned that off. Well, it also has the performance hit that every time you connect to the Metastore, you're having to ask it, are you provisioned yet? Does this table exist? Do I need to go create this table for you? So we got rid of that. We now turn on SQL Standard Authorization by default. So in the past, Hive had some kind of authorization mode, but it was very, I don't know, to call it authorization or security was extremely gracious. It did have grants and revokes, but anybody could grant anybody anything. So that's not much of a security system, right? It was mostly there as kind of bumpers, to keep you could revoke privileges from a table so that you didn't screw up and drop the table or something, but it wasn't honest security. SQL Standard Authorization, which it just is authorization based on the SQL spec. This was added several releases ago to Hive. That's now what we turn on by default. So that's real grants and revokes and privileges, roles, all that kind of stuff that you're used to from other databases. So one other big thing is the Hive command line interface is still there, but we've deprecated it. And our plan in the future is to actually kill it. Now, that doesn't mean you can't, our plan is you can't someday talk to Hive on the command line. That's certainly not true, because we have this tool called Beeline that allows you to issue command lines that are then sent through Hive Server 2 via JDBC. But we want to constrain that to, that's the way you talk to Hive. Why is that? A couple of reasons. One is, you cannot secure a cluster when users are on gateway machines inside the cluster and directly talking to the cluster, directly accessing files. Columnar security means nothing if your user can actually directly access that file in HDFS, because Hive might tell you, no, you can't see that column, and you just say, well, forget you, I'm going to just read the file, and then I can see the column. So clearly we can't, we need to be able to lock that stuff down. So we need a standard approach where when you're connecting to Hive, you're coming from outside the cluster via JDBC or ODBC. The other thing is, just from a coding and development perspective, it's cleaner to have one path. We need to have one way that people get in and out so we can put all our effort in maintaining that. Now, why haven't we done this so far? Why did we only deprecate it instead of just removing it? The answer is because there's still some options and features in Beeline, or in the command line, that are not in Beeline. And we know that we have to have 100% feature compatibility in Beeline before we move. If we just switch the command line on you and say, ha, -c used to mean this, now it means something else, there'd probably be a revolt, right? So we don't want that. We want to make sure that whatever bash scripts or however you used Hive before from the command line still works for you. And that's work yet to be done. Okay, with that, I say thank you. And if you have questions, I don't know if there's a mic up here, or if you just raise your hand. I guess you can raise your hand and I'll repeat the question. But thank you very much. Yes. Yes. Yeah, so Beeline, after I just said that you want to lock down the server, Beeline actually does have a mode where it can embed Hive Server 2 itself. So if you really truly want that mode, where your user's on the gateway and they're running like that, you can still enable it. We would just tell you that that's a bad idea, right? But if there's some burning reason that you need it that way, you can do it. Does that answer the question? Okay. Yes? Can you run Hive 1 and 2 in the same cluster? Yes. So the one challenge is we don't promise going forward that the Metastore will be compatible. So you could certainly run them in the same cluster, but sharing the same data set between them is not something we promise is going to work. Does that make sense? Okay. Yes?
How you're planning to migrate existing Hive Metastore, which stores in the RDBMS, to HBase?
So yeah, what's the migration plan from Metastore, from RDBMS to Metastore? So we built tools to do that migration, but it won't. So much of Hadoop, including Hive, can now do what we call rolling upgrades, where you don't take the cluster down or anything like that. We don't support that because we just couldn't figure out a way to manage that. But what you can do, and we've tested this internally. You turn off access, you run this script which just pulls everything out of the relational database, dumps it in the HBase store, you flip the configuration to move to HBase, and it goes. So there is a small amount of downtime, but it's a one-time thing.
Is it possible to run them in parallel, have the Hive Metastore and RDBMS as authoritative one, then you switch, and then you phase out the...
So the question is it possible to run them in parallel? The answer is maybe. So I actually wrote code to do that because it's not that hard to make it so that one's authoritative and one's backup, and everybody else told me to put down the crack pipe because they said that's just nuts. Now you've got, something's going to go wrong and you're going to have one out of sync with the other. So that's kind of an unresolved discussion in the community about whether we do it where there is somebody's the right answer and somebody's the trailer, and then you can switch that at some point once you've gained confidence in the HBase Metastore, or whether we just say, no, you got to jump whole hog. We'll kind of...
I'm writing this question just because I'm afraid when a lot of people will start switching, it will be a nightmare.
Yes. Well, you're the reason I wrote that layer, right? I mean, you gave me the original idea. So yes, I went out and wrote it, and then, because I thought it was a good idea, but we haven't convinced everybody else yet. Yes, way in the back.
Do you think cost-based optimizer will choose between LLP, Tez, and Spark at some point?
So do I think the cost-based optimizer will choose between Tez, Spark, and LLAP? I would be surprised if it were choosing Tez or Spark. That's kind of an installation choice, because there's a lot around that you need to do when you set it up. But between LLAP and, am I going to run this in LLAP? I'm going to run it partly in LLAP and partly in Tez. I'm going to run it all in Tez. That, yes. We're not there yet, but that is definitely what we want. Right? That's the right way to approach it. Oh, yeah. Any other questions? Oh, over here again.
When I was actually using Spark as sampling engine, would the optimizer be actually delegated to a Spark optimizer? Or
So the question is, when it's using Spark underneath, does it delegate to Spark's optimizer? As far as I know, what it does right now is it still builds its own optimization plan, and then Spark obviously underneath may optimize that some more, but it does not just push work down to Spark today, as far as I know.
Sorry, follow-up question. So in that case, how is it going to cope with changes in Spark, like say dynamic evaluation and like the new transient changes coming in?
Yeah, so how's it going to cope with changes? As Spark basically matures underneath and builds its own much better optimizer, how's it going to make use of that? That is honestly a really good question that I don't have an answer to. I'm not super involved with the Hive on Spark work, so I don't know what their answer to that is, but I suspect the answer is they'd have to make changes in our optimizer to realize it should back off and push more work down. Whether that's their plan or not, I don't know. I think I saw one, did I see one there?
When you presented performance benchmarks, your query names were up to query 98.
Right.
What happens with the rest 30?
Oh, so yeah, when I presented the benchmarks, it only went up to query 98 or something. What happened? The real benchmark goes to query 107 or 120 or something, right? The answer is Hive can't actually execute all of TPC-DS. There are still some queries that it doesn't have the SQL to execute. So what you saw there was the 70% or whatever it is of the queries we can actually execute. Yeah, thanks for clarifying that. Yes?
What is the relation to Kylin?
What is the relation to Kylin? So Kylin uses Hive for some things underneath. It also uses HBase, I believe, for some things. But they are, to us, a layer on top that uses Hive. We haven't looked at deeply integrating with them beyond that. Okay, I believe, yes, the red light's flashing. That means I need to shut up and get off the stage. So thank you very much, everyone.